So we're here today to talk about the Reliability Toolkit, which is a monitoring and alerting stack that we built ourselves. It's mostly made up out of open source software. So we hope that by sharing our architecture and way of working around it, that it might inspire you to do to see what you can use for your organization and whatnot. So we're Robin and Janna, and we work for a bank. We feel like we work for an IT organization and not so much a bank, so the only cash we really like is Johnny Cash. So we're very happy to be in Nashville. Really have enjoyed the city so far and the hot chicken. What I do is I'm an IT chapter lead, which means that I spend 40% of my time doing HR work, coaching, yearly appraisals, and like development of people in my team. And I spend 60% of my time contributing to a team, which was the SRE team up until 3 weeks ago. So we're going to be talking about that specific team. And now I moved to be a product owner to another reliability engineering team.
Robin, I'm the product owner of the site reliability engineering team, and I'm a SRE myself. So basically, I'm responsible for what we do as a team and make decisions on our priorities.
Yeah, so to start off, we would like to share a little bit of background so you can get a feeling of our organization and our team and what we do. So we are a team of 7 SREs, and we support 1,700 engineers in the organization. This means that we do not follow the Google model where we take on-call responsibilities, but we try to automate and engineer solutions for other teams. Our main goals are to reduce the mean time to repair and increase the mean time between failures for all IT services within the bank. So our solutions are also based on those goals. So why do we do this? As a bank, we need to reach some availability targets set by or expectations from customers or regulators. So the regulators actually demand a certain availability percentage. But also, for example, last year we had a major incident on New Year's Day when people couldn't check their balances anymore on their phones. That sucks if you spent the night drinking and partying and well, you cannot see how much money you still have, or you cannot transfer money to your savings from your savings account. And that actually ends up in the national news for us. So whenever there's an outage for ING, that like on the online channels, that's longer than a certain amount of hours, then it's a headline on the news websites. So that can be pretty annoying and does not help with our reputation. So like I said, we enable other teams. So I think there are roughly 300 teams. We're also expanding to not only supporting the Netherlands, but also Belgium IT. We do this with engineering. So we deliver tooling, but we also do some consulting if there's major incidents reoccurring. And we do some education on topics related to SRE. And our main product is the Reliability Toolkit. It's monitoring and alerting. We also have been working on a ChatOps platform, Mattermost, which is a sort of open source version of Slack. We facilitate some postmortems, and like I said, we do education about related topics.
So when we started like 2 years ago, our assignment from the management was like, okay, you're going to improve reliability of all services within our domain. And it was like 300 teams, and we had no idea where to start. So we head out and checked where to start when you have to improve reliability, and you have this really awesome Google SRE book, which has this reliability hierarchy with monitoring as a fundament. And what we've seen throughout the organization is that there is a lack of great monitoring. So the first thing we've seen is that our mean time to repair is too long. In 2017, it took like an average of 69 minutes before the alert arrived at the responsible engineer. And it was measured through our major incidents. So that's functionalities like doing a payment, doing a safe transaction, checking your balance, stuff like that. So the real important stuff, it took like 69 minutes before the alert ended up at an engineer. We found that the challenge we needed to solve as an SRE team. So the other reason why we chose to start with the Reliability Toolkit is that we measured the availability of our business functionalities. But when we arrived at a team after a postmortem or something, and we asked them, okay, what's your availability rate of your application? Most of the teams weren't able to answer that question. They don't even know. So, so we had like this black box monitoring tool was measuring our business services, but we didn't have any tool measuring the services for the application from the application perspective. So the white box monitoring wasn't really there. There was something like Graphite, but it was like 10 minutes latency on Graphite, and we had EOK, but I only know the Kibana screens from the spinners, so it wasn't really working for the teams. The other thing is that we have like this great diversity in technologies within ING. Yes, we do have Java APIs. Some things are running in Docker, but we have mainframe as well. We use Oracle databases, and we use Cassandra databases. We have message queue systems, we have typical services. So we have all kind of technologies. So we needed to come up with a white box monitoring solution that had like this great fit on any kind of technology. And we wanted to create something that was easy to use for engineers. If you want to run a service within ING, you have to fill in like dozens of documents, and you do that to prove that you're in control of your risks, because that's what we promise to our regulators. And that makes it quite hard to create new technology or to use new technology within our company, and that's why we chose to create Reliability Toolkit and to take care of all the things you should do to create new services. So what's in it? First of all, Prometheus. Because Prometheus has all these kind of exporters and integrations, it makes it highly adaptable for our environment. The other thing is it was highly scalable, and it has an alert functionality, and it was just what we were missing. And this is what we want to use for this 69 average on the mean time to repair.
Maybe you should explain what it is.
Prometheus itself.
Yeah.
Oh yeah, yeah, that's a good one. So Prometheus is like this time series database, kind of comparable to Graphite, but then it's like a time series database with an alert functionality. So you could alert based on time series, basically. Check?
Yeah.
Awesome. And it comes with an alert manager as well. So Prometheus is there to create alerts based on time series, and then you have alert manager to route the alerts to your phone or your chat ops solution or your mail if you want to. And then we deliver Grafana, because Prometheus comes with visualization, but it isn't that great, and Grafana is awesome, so we deliver Grafana as well. And then we created something called Model Builder, because what we wanted to use is like this expectation on metrics. So we're going to expect this many payments now, and now we want to compare it with the real-time metric to have this kind of anomaly detection. So that's why we created a Model Builder. So how does it work? Let's assume you have an application that's doing like saving transactions. Then you have Prometheus, and Prometheus comes by every 10 seconds, every 15 seconds or so, and it's going to ask, okay, what's the state right now? What's the state right now? What's the state right now? The state is stored in a time series database of Prometheus, and you could create graphs on it with Grafana. Then you could create like queries, and on the queries you could create alerts with thresholds, and the alerts will be sent to the alert manager. And within Alert Manager, you configure, okay, this type alert needs to send to my mail because it's not that important. The other one needs to be sent to SMS. We use MessageBird for that. And the other one might be sent to my ChatOps channel. And we use Mattermost for ChatOps within ING because it runs on-premise, which is kind of important if you're a company like ours.
And I think it's also good to mention that for the SMS, we chose MessageBird and not the text services we already offer like in-house as a bank. Because if a person does a payment, they get a text message with a code authorizing the payment. But we didn't want to interfere with business traffic for this kind of purpose at all. So that's why we took out a separate contract for that. So a little bit about how we provision this stuff and why. So together with a team, we create a config. And in the config, there's already templated dashboards and some predefined alerts, also alerts for ourselves and for the team. So it's easy for everyone to use the toolkit and they don't have to reinvent the wheel all over. I think that's sort of a general pattern in how we try to set up things. So we also talk to teams and see what templated dashboards will actually help them. So it's like plug and play, basically. We maintain and update the binary. So if there's like a new version of Prometheus or of Grafana, we test it, we release it. Because we do this ourselves, we can do it very quickly. It's not always easy to release something very quickly within the bank, but because we have everything in our own control, it's easier to do so. We also take care of security testing and penetration testing. So we meet all compliance requirements and no one has to think about that ever again. What we do is we actually deliver 5 machines to teams, 1 in test, 2 in acceptance, and 2 in production. So they also have full control, well, almost full control over their own set of machines, and others cannot fully interfere. We remain responsible for patching, so the teams have the benefits, and we take some of the pain away for them. What we also do is we deliver some client libraries. So we have some engineering frameworks that are used within the bank to build your APIs much quicker. And we made sure that those types of applications in the framework itself, there's client libraries included. So people can easily start out with Prometheus and they don't have to adjust their applications if they want to start using it for those generally used ways of working, so with the APIs. We also have other teams working on exporters. So as Robin said, we have a lot of different technologies. So for example, someone who has been using our toolkit was so excited about it and he created an Oracle exporter. But then we also want to make sure that we can share that with all the other engineering teams. So there's sort of an internal open source environment where we can reuse the work that's already been done. And that really helps. And also by having the client libraries reused, we can make sure that the labeling is similar and that people can reuse each other's data. So we've been working on this toolkit for quite some time. And in a previous version, the ones it's also still running, teams would get like a full pipeline to do configuration changes with GitLab for version control, templating through Jinja, Jenkins and Maven for the build, Artifactory for publishing, and Nolio for deploying. We set up the pipeline like this because it's very similar to the pipelines that teams have been using within ING for a long time. So we wanted to take some products and tools that are familiar to them, so they didn't have to relearn everything all over. And what was the case in this one is that the DevOps teams actually had to do a lot of work themselves because we wanted to give control to them, control of how they could deploy and everything. But turns out after some feedback, we changed this, and now teams only need to update the config, and then we take care of the build and deploy with Ansible. So we actually learned throughout what needed to be changed and what people prefer. And also we prefer Ansible over Nolio, a lot nicer. So just delivering cool technology, something we've also learned, just having cool technology doesn't mean that people start using it straight away. I think there's also another talk about it at this conference. So we actually needed to do some work for that. And we learned from that as well. Like I said, it helps if client libraries are included in engineering frameworks. People actually are surprised when they see that they already have the metrics available before they start onboarding with us. So that's really cool. A good feedback loop with your customers. So at first we had a lot of people wanting to onboard, and they actually joined our onboarding sessions, but they didn't always use the product afterwards. So we check in with our customers and see what's inhibiting them from using it, or maybe sometimes even planning that conversation, that feedback interview helps to trigger that people actually start using it again, or like, oh, I needed to do this one thing and then it starts working. So that's actually been pretty good. It takes some time to talk to everyone individually, but like the benefits so far have been clearly there. So we also educate engineers. Something that we've learned is that because we have been interested in the field of SRE and monitoring and operations like for a really long time. So for us, monitoring, our basic monitoring level is like knowledge is quite high. But turns out that if we talk to other teams, that they lack some of the basic knowledge or concepts, which makes it even more difficult to start using a thing like Prometheus, where you have to do quite some things yourself or know a lot about before you can start. So we even had it happen that we did a demo, and that I showed all these kinds of metrics and dashboards, but someone came up to me afterwards and they said, oh, that's so cool, but I just spent all my time getting all my stuff into Elk, so that's a waste. But Elk is like log monitoring, and this is more based on metrics, so it's like two different ball games, and you need both to get like a full picture of your application landscape. But for some reason, that message wasn't fully processed, so we created materials about monitoring. So we give a monitoring class to new engineers, where we talk about the concepts and not just tools, because there's also often tool obsession going on within our company, unfortunately. Or sometimes people have been doing monitoring just because their manager told them so. So we help out a little there. And we also created workshops for people to use our toolkit. So we have a workshop focusing on the query language that you need to know before you can use Prometheus. And we try to set it up in a way that it really matches with what engineers want and how they learn best. So by doing exercises using fake metrics. And we'll also show you that later. What we also did is we built a tool that scrapes metrics from the Nginx layer. And that ensures that application metrics for a lot of teams that use Nginx are already accessible in dashboards. So it's easy to show the benefits of using this type of monitoring to teams, because we already have some data for them. And we'll also show you that right about now. So let's hope everything still works.
Another good thing to know is that we had like this first user community on Thursday, which was hosted and organized by our users. So without our interference, people are starting work together and starting to learn together about the Reliability Toolkit, which is awesome. So yeah, demo, the exciting part, right? So we created this application that consumes Kafka, and there is a topic on Kafka where all the access log data from Nginx is. So we have a lot of information about applications that run directly behind Nginx, and it looks a little bit like this. So we have this Nginx log aggregated, but it doesn't really aggregate, but still, it consumes the Kafka topic, and Nginx is producing his access log data on the same topic. So let's go. So what you see here, is it readable for everyone? But you are at the front, right? What? Otherwise I could just zoom in or anything. Is it good?
Or maybe just talk through it, what's on there.
All right. So what you see is like we have this error overview dashboard, and we use this to see if there are any applications sending out a lot of alerts based on our metrics, so what we find of their application. And let's see that we have like an application sending all kind of alerts here, and it's called Unica Suite, newest tech campaign. And what we do is then we select that application and we click through it and we see if there is more information on it, and usually there is. And then we go to the responsible team, which is stated here, and the team name is horrible because it says no team known, but that's the actual team name. No joke. So then we see the team, and then we could see if they have like difficulties with their application, and maybe they're aware of that, and maybe they don't. Maybe they need some help. Maybe they don't want any help. But what we could do based on this dashboard is that we could go to the team and see what's happening there, and tell them, okay, we have all these cool alerts about your applications. Would you like to receive those alerts? And most of the times well, I expect that they want to receive the alerts. But we could also say, okay, maybe you want to have monitoring for yourself. And that's great because we have something for that, and it's called Reliability Toolkit. And more or less, then we could give them Reliability Toolkit, and then they need to configure this kind of stuff themselves. And I'm about to show you how this works for teams. So basically, this is Prometheus. This is something about the rules. And what you see here is that these are our own rules that says something about our stack, because we feel responsible for the stack that we deliver to a team, that we provision to teams. So we receive alerts about the stack. And this is like one part of the configuration we combine with the team configuration. And then I created an alert rule, which is around here, which is called SRE demo. Very creative. So let's change it. So let's see. We're still here. Great. I'm not going to change this one. So as you see, we have all kind of default alert rules, all kind of templating, example dashboarding, because we deploy the dashboards as well, so we give them all kind of templating stuff. This is the alert rule file, and as you see, it says something about the name of the alert, the name of the alert rule file, the group, and I'm just going, this says something about if there is a service down, it will go into alert, and I will just change the 0 into 1, so it will alert when things are up. And Janna is at the endpoint, so she will receive the alerts in her mail. So let's see if it works. Oh yeah, I'm committing the file to our Git repository, and I have to say what I changed. So I changed the 0 into the 1 in front of a big audience. Oh, typo. It's okay, I guess. And I'm going to push it, and okay, it's going to take a while because I need internet, and then we have this latency all the way to Holland, and it worked. Okay. So now our Ansible master is supposed to pick it up, see that there are changes, and they said, oh, cool, there are 8 changes into this configuration. And it's going to do all kind of validation to see if there is any typos, any things that could break your monitoring stack, for example, or could break any other stuff. And we're going to check that. And after the validation, we're going to deploy it to your stack, and it should be there. So let's see, Zijll. $11.25, starting deployment. We'll see if something will happen. Refresh. I think I just missed the deployment, because what we do is we fetch every 5 minutes or so, and then we deploy every 10 minutes. And this is the test environment, so this is far less frequently than production, for example. So we have to wait. if you don't mind. Yeah, sure. Okay, just going while waiting, Janna is going to show you something about our training material.
Yeah, so about the workshop I was talking about before, we actually published it on Confluence, which is our knowledge sharing website, and searchable for everyone who has ING credentials. At first, we only gave it during like actual workshops because we wanted to test how everything worked, and we wanted the immediate customer interaction, as it were. But then we decided that every piece of knowledge that we have should be shared and accessible to all. So we published it here. So we actually created an application that delivers fake metrics, but they're still understandable, like fake metrics for ing.nl, ing.de, and then we ask people to do exercises on them. So here there's some basic explanation of what our components actually do. A lot of screen caps showing people how to log on and go someplace. But here's just an example assignment, because the document, I don't know how many of you have worked with Prometheus, but the documentation on Prometheus querying language can sometimes be a little bit limited or difficult for people to like get up and running with. So that's why we made this ourselves, and we hope in the future that we can also maybe open source something like this, so other engineers can benefit. So at first there's a little bit explanation about the theory behind everything. Then there's the assignment. And after the person has created the query showing the number of customers for each site, so that's for ING.de, NL, BE, then they can actually see what the solution should have been. So everyone can go through this by themselves, because we also learned that by doing the physical workshops that the one person needed 3 hours to complete everything, but the other person was like done in 1 hour, which wasn't very motivating for the one taking longer. So that's why we came up with this solution. Should we check if it has deployed? Yeah? Yeah.
Let's check. Didn't you receive any email?
Oh, yeah.
Just kidding.
I put away my phone, so I cannot check.
It hasn't deployed yet. It is successful, but I think it just missed the deployment. So we have to wait another 5 minutes, but
that's almost done.
Yeah.
It's almost through.
Yeah. So let's get back to the presentation, where I could tell you something about our model builder. So we have like this a load on our systems, which is kind of similar every day, but it differs kind of in the weekends and on working days. Because if I'm doing my banking business, I'm not doing that in the weekend. I'm doing that during business days, I guess, and not in the middle of the night, but during the day. So we have like this expected traffic. And what we did is that we created a Java application where you could use any Prometheus metric as input, and a model builder will just analyze and create a model out of it of the same metric. So let's, for example, take HTTP total requests, so all your requests on HTTP. So what it does, it creates another metric, which is called model HTTP request total. And by doing that, it's going to expose it to Prometheus, so Prometheus could scrape it again. And within Prometheus, you have like 2 metrics, and you could compare those 2 metrics. So let's assume that we have a load of 10 TPS, and we expect a load of 100 TPS. Then there might be something wrong, and you want to receive an alert on that. So you're basically able to receive alerts on an anomaly detection, an anomaly like this. So we have the current load, and we have the expected load, and this might be like this potential alert. You could do this on load, but you could do the same on errors or any other metric that there is in Prometheus. We created this ourselves, so this is custom built, and we're looking into open sourcing this as well. So let's see. Is this still a demo ghost or did it work? Yeah, still 0, right?
It's only 31.
Hmm? Well, it's starting its deployment. Come on.
Yes.
Success. Yay. I'm so happy. So then it should start firing in a couple of minutes. I think it takes another 5 minutes, so I guess we could do any questions.
Yeah.
Do you want to go to the question part?
Yeah.
Okay. So if anybody has any questions, please head up to the microphone there in the middle of the room. Just take time.
Yeah, so I'll repeat that just in case you weren't. So if you have any questions, please walk up to the microphone. If you're in front, we're okay with screaming out the question and we'll repeat. So whatever suits you, as long as we can hear it. Yeah. So you said, how do you solve the ownership of Prometheus servers, and then? Do the teams own their own Prometheus setup and alert manager?
Shall I do it
Yeah,
as a product owner?
sure.
All right. So we take ownership of the service, of Prometheus, and of everything else. So practically, that's Prometheus as a service. You're welcome.
All right, we have a question here.
Okay.
Hi, I'm Gerard. So how could do you have Model Builder outsourced? Like, can I use it? Like, I'm using Prometheus, Grafana, all those tools already. How can I use Model Builder?
Yeah, so we hope in the future to open source it. So, well, Robin needs to prioritize it as product owner, but we really hope to spread this, but we haven't thought of a way of how to inform people of that yet. So maybe come to us after, and then we can write down your email address.
Yeah.
So once we know it's out there, or we got it out there, then maybe you can test it and see if it works.
Okay, another related question to Model Builder. How do you manage the alerting? Does it feed back into Prometheus, and then you do Alert Manager, or how does it work?
So how do you manage the alert?
Yeah, so with this now you can detect alerts depending on your models, right? But what triggers the alert? What alerts and how do you plot this? Does all this information get back into Prometheus?
So the model builder exposes the model as a metric to Prometheus. So and then you can alert on the metric within Prometheus just like any other metric.
Okay, thanks.
Can you repeat the question?
Or we allowing the teams to alter their Git repositories in the configuration within Git, right? For the alert checks. So what I showed you, what I demoed you like 10 minutes ago, that's how teams are going to use it. So they are responsible for the configuration. The only thing we're doing for them is that we check on, we do validation checks that it still will work after the configuration change. No, it's automated.
Yeah, so no human checks there.
No, please no. because I can imagine that a team will show up in the middle of the night solving an incident and is like, okay, but we need this extra alert, and then it needs to call me to check it. No, please no.
Yeah, but still, if there's people who want to know a little bit more about how to configure those alerts, then they can always drop by our desks and we will help them, of course. So that's, I guess, the human check that we do offer.
Sure.
but not in this case.
All right, I had a question, breaking the rules here with session chair. How do you drive adoption of this? You said you have 300 or so teams. What are some of the mechanisms you try to get people on board with this, and how successful have you been?
Yeah, so that's also the NLA dashboard, where people can look at all the data that we already have. We've also showcased this to like the major incident resolvers. We have some major incident coordinators, so we also showed it to them, so they will get it up on their screens. And like we also made on our whiteboard, there's like the URL to it, and we showcase it at demos. So we do that. We invest quite a lot in demos. We do monthly demos also for our team's work, for which the invitee group should grow continuously. Getting teams to actually use it, it can be difficult because we also spend time like transitioning to the new stack. Because the old one that we showed with like the full pipeline that teams actually used, it was in an infrastructure stack that actually filled up. So we all need to move to a private cloud, but that means that our solution needs to be ready for the private cloud, and we're almost there. So we've had quite some hurdles in the way of getting mass adoption, as it were, but getting there and really talking a lot about it as well.
Yeah, great. Thank you.